Hey kids, this is Mr. Cozy, and today we are going to talk about simplifying radical expressions. This is video number 5. We will look at adding and subtracting radicals, multiplying and dividing them, and then add variables into the mix. So here we go. The bummer about adding and subtracting radicals is that it usually doesn't work. Because what everybody wants to do, here's the mistake that every student that I've ever had has made, is they've looked at something like radical 3 plus radical 5 and have gone, oh, well, I can just add the 3 and the 5, so this is radical 8. Or even worse, they do that in reverse and go, oh, I can just write this as x squared and y squared, so this is x plus y. Okay, this never works. And if you wanted to check to see why, in your calculator put in this and then put in this and see how they are not the same. Okay, adding and subtracting radicals is very picky. If I have radical 3 plus radical 5, I can't simplify this anymore because I need the same number under the radical. I need the same radicand. But also, I also need the same type of radical. So radical 5 plus square root of 5 plus cube root of 5, I also can't simplify or crunch down because the radicals are different. To add and subtract radical expressions, I need the same radical and the same radicand. So something like square root of 5 plus square root of 5. Now, if you recall, the rules for how to simplify this are exactly the same as the rules that you use when you combine like terms. So if I have x plus x, we know that there are ninja 1s hiding out in front of these x's, and that's what I add up. 1 plus 1 is 2x. Likewise, square root of 5 plus square root of 5 is 2 square root of 5. Okay? And if I have something like 5 radical 3 minus 2 radical 6 minus 3 radical 3, okay? These two terms have the same radicals, so they are like terms. This is the odd man out. So I combine these two terms. A 5 minus a 3 is 2 radical 3, and then this last term I just smack on to the end like that. Okay? Radicals have to be the same for you to combine them. Now, there is a catch, because there's always a catch. This is math class. The catch is that your radicals need to be simplified. So if I look at something like 3 square root of 8 minus 4 square root of 2, these radicands are different, but I can simplify this 8 here, because square root of 8 is 2, or 8 is 4 times 2, and I can take the square root of the 4. So this is going to be 3 times 2 times radical 2, times radical 2. Okay? This 2 stays under the radical because it is not a perfect square. The 4 does not. I can take the square root of that. Now I multiply the 3 and the 2 together to get 6 radical 2 minus 4 radical 2, and that gives me 2 radical 2. Okay, so simplify your radicals and then combine like terms. When you're adding and subtracting radicals, the name of the game is like terms. The good news about multiplying and dividing is that all of the things that you want to be able to do when you add and subtract, you can do when you multiply and divide. I have square root of 3 times square root of 2. I can just put those under the radical and multiply them together, radical 6. Okay? Now, the radicals still need to be the same. If I had a cube root like this, I couldn't simplify this at all. This would be done. So your radicals have to be the same, but if they are, you can just multiply or divide the radicands and get your answers. Okay, so square root of 5 times square root of 3 is square root of 15. If I am dividing, square root of 20 divided by square root of 2. Like multiplying, I can just put that under the radical. 20 divided with 2 is 10, square root of 10. And if there are numbers already outside the radical, no problem. I just keep them separate from the numbers under the radical. So 2 times 3 is 6, and then 3 times 5 is 15. Okay. Now, throwing variables in the mix, nothing changes. All of the rules that you've learned about multiplying exponents and simplifying radicals still applies. So let's take a look at an example, and then we will call it a day. If I have something like square root of 5x squared y times square root of a 15 xy, okay? Once again, I multiply what's under the radical. So the 5 times the 15 is 75. X to the second times x is x to the third. Y times y is y squared. And then I simplify this radical. 75 is 25 times 3. So I get a 5 outside and a 3 inside the radical. X to the third, dividing this with 2 because that's the type of radical. This is a square root. Dividing 3 with 2 gives me a quotient of 1, so x to the first, and a remainder of 1, so there's an x to the first under the radical. Dividing 2 with 2 gives me a quotient of 1, so y to the first, and here's my simplified result. Okay, to review, nothing has changed from what we've learned in the previous video. I've just added on this new rule about simplifying radicals that we practiced yesterday. Okay, so we'll cut this off here. Tomorrow we'll look at a few more examples. We'll look at rationalizing denominators that have radicals in them, and we will then do some more practice. But for now, I think we are done. So have a great day, and I will see you tomorrow.